So what happens if I am given the derivative of a function? You can see here that we are given the f prime, the derivative of our function f. What happens if I want to find my f of x? Well, we're just going to want to go backwards. So let's examine our function and see if we can go backwards. If you remember when we found the derivative, we always took our exponent and we multiplied it to the front and we subtracted 1. We want to go reversed, so we want to do the last operation reversed first. All that means is we're going to add 1 this time. So we know we're going to have an x to the 4th. Keep our 4. And then we want to divide by our new exponent here. That number is going to go on the bottom. So for the next one, we have a 6x. Remember, there's an invisible 1 here. So I'm going to add 1 to my invisible 1. And that's going to give me 6x squared. And again, I divide by my new exponent. So I'm going to divide by 2. Now our 4 is a little bit tricky because before we always just had our constants disappear. But this time we need to bring in some x. If you remember your algebra, there's actually an invisible x to the 0 next to any constant term. So what I can do is if I add 1 to my 0, we get x to the 1. We get 4x to the 1, minus 4x to the 1, and we divide by my new exponent. So I'm just going to divide by 1. So when I solve this, you'll get 4, no you won't. You will get 4 divided by 4, those cancel. They'll just get x to the 4th. 6 divided by 2 is 3. Plus 3x squared, and then minus 4x, and that 1 can just be left blank. And this is our original function. So let's go ahead and check our answer. You can see here we have our f of x that we found from before with the original f prime that we were given. So let's go ahead and check our answer to see if when we check it, do we get the same answer. So we're going to take my exponent and multiply it to the front, and we'll get 4x. We drop our exponent down 1, 4x cubed. Do the same thing. We bring our exponent to the front through multiplication. 2 times 3 is 6x, and we drop it by 1. And then remember, we have an invisible 1 here. So when we take that to the front, we're just left with minus 4. We can see that indeed our derivatives are the same. But let's see what happens if I modify my f of x just a little bit. If I were to take my f of x and add a constant, what do you think is going to happen? Let's say I do plus 8. You see, this is a different function than our original value. It's not the same function. We added 8. Let's find the derivative. Call this, say this is f1 of x. It's a little bit different because we added an 8. If I take the derivative, again, take my exponents, multiply them to the front, you'll get 4x, f prime of x, equals 4x cubed plus 6x minus 4. And again, our 8 here is a constant term. It's just going to cancel out and become 0. Well, this seems very confusing. Because now we have two functions. Let's go back to here. See if we can make this guy smaller. Maybe I can't. We can zoom out though, that'll work. So let's say I have that function, and let's throw my original function back in. This was the modified function, f of 1. We have my original function, which was just x to the 4th plus 3x squared minus 4x. And we found that both of these functions have the same derivative. So we don't know which one is the actual real original function. Both both my f of x and my f of 1 of x are correct possible solutions for my f of x given the derivative. So that was the review part. Let's learn something that we haven't learned before. Let's go ahead and learn something new. We can see here that I have given you the derivative of some function. Dy dx is just another way of saying f prime of x for some value y. We're going to learn how to take the antiderivative. Now luckily that's what we've just worked on, finding the derivative. Given the derivative, find the original function. So if you go back a few minutes in the video, we can find that y prime, if you remember, we said we take our exponent, we're going to add 1. So this is going to be 2x, 1, that's invisible 1, plus 1 is 2, divided by my new value, so divided by 2. But if you remember, I said before that if I add anything to this, I could do plus 8, I could do plus 7, I could even do minus 4. If I put any of those in, and when I check my answer, it's going to be the same. So since I can use any number, any constant, what we're going to do is add a plus c. So don't forget your plus c. Okay? And then we can simplify. 2 divided by 2, they're just going to cancel. You'll be left with x squared plus c. And that is your antiderivative. So sometimes in math, we use different notations and different words to mean similar things with a little bit of a twist. So let's say if we want to find the antiderivative, that also has another term. We would say to find the antiderivative, you take the integral of some value. So let's say I had some value, dy dx equals negative 24x to the 5th. If I wanted to integrate both sides, we use this little kind of stretched out S looking thing. Alright? Now there's a problem over here that, well, I won't get into why it's a problem, but we'll just fix it first. We can't have both dy and dx on the same time with our curly Q here. So all we're going to do is we're going to multiply both sides times dx, and we're going to get that the integral of dy, remember we've seen dy before, it was a fancy way of saying y prime, is equal to the integral of negative 24 x fifth to the dx. Now, don't be too nervous about this dx. In the end, it's just going to disappear when we look through the example. So let's keep going. If we wanted to find the integral or the antiderivative of negative 24x to the 5th, well, because we're now performing the operation, we're not going to have the curly Q anymore. We're going to take our x to the 5th, and remember we said we're going to add 1 to the exponent, and then we're going to divide by that exponent. And remember before I said my dx just disappears? Well, now's the time. Once we do the integral operation, the dx and the curly Q symbol both disappear at the same time. But I am forgetting something. Do you guys remember what I told you not to forget? The plus c. And now I can simplify. And we're left with the y equals negative 24 divided by 6 is negative 4 x to the 6th plus c. And that is the integral of that value. So let's finish our examples with one with a little bit more complicated, but it all follows the exact same rule. At the end of the video, I'll put up a nice little easy to use formula for you to look at. So again, we're going to use the same exact rule to find the integral of dy dx equals 8x to the negative 3 plus 3 square root of x minus 2. So when I take the antiderivative, remember we said we can't have dy dx on the same sides. So we'll have 8x cubed, 8x to the negative cubed, plus 3 square root of x minus 2, and we're just going to bring the dx over. Alright, this is the step before. If you remember from the last time, I just multiplied both sides by dx, and those will cancel, and we're left with the dx over here. So as I take the antiderivative of both sides, the antiderivative of dy is just y. what's going to happen over here, we're going to take our exponents and we're going to add 1. So we're going to have 8x. Oop, let's make that white. So you're going to have 8x, negative 3 plus 1 is negative 2, divided by my new exponent. Now if you remember, 3 square root of x is really just 3x to the 1/2. So I'm going to add 1. So I'll get 3x, 1/2 plus 1 is 3/2. And I'm going to divide by 3/2. And then negative 2, here's a little shortcut for you. Whenever you're doing an antiderivative of a constant term, you just bring on an x. Because remember, there is an x to the 0 here. So we would technically have a 1 here and divide by 1. But you can always just throw on the x, and that makes it simpler. The dx is going to cancel just like my dy did, and I get my plus c. So let's zoom out a little bit here so we can simplify. So we're going to end up with y equals 8 divided by negative 2 is negative 4, x to the negative 2. 3 divided by 3/2 is 2, oop, not equals, plus 2x to the 3/2 minus 2x plus c. And this is a good answer. We have some negative exponents and some fractional exponents, but this in calculus is a perfectly fine answer for your antiderivative. So like I said, I want to give you a little formula here for any time you need to find an antiderivative or the integral of some derivative. So if we want the antiderivative or the integral of dy dx, that's going to be integral of some polynomial function. We have a constant in the front, some constant a, for x to some power n. And remember, n doesn't have to be a whole number. N could be positive, could be negative, or a fraction. Doesn't matter. Any of those three, we're still in good shape. So all we're going to do is we're going to take, that's not right. All we're going to do, we're going to leave our ax, we're going to add 1 to our exponent and divide by that value and add our plus c. And if you don't like that format, some people write it like this. Just your constant being divided by the new value. And if you want to pause your screen and look at this while you do your work, this would be a good formula for you to do. So this has been my first video. I hope it helps. Expect more videos from me as we continue. Thank you very much. Good luck, students.